Okay, this question is cool. I love this question. Because what it does is it showcases the exact strength of this kind of technique. Okay? Have a look at this. This is hyperbola here, this curvy part here. 1 over x. Right? So that's why I've labeled an arbitrary point on there. I should have put it somewhere else, but anyway. If I have some supplied x coordinate, then the y coordinate corresponding to that will be 1 over x. No problem. Okay? Now, if you think about this, of course you could rotate it around in something vertical or horizontal, but the great thing about it is that you guys recognize this. This is a rectangular hyperbola, right? Cool, right? So in fact, because it has this, if you look at it at 45 degrees, it has this symmetry about y equals x, right? That's really cool, right? It is its own inverse, right? Because when you swap your inputs and your outputs, your x and your y's, ta-da, you still got the same function, okay? So when you flip it across 1 over x, when you flip it over y equals x, you get back the same function, okay? Now that's really cool because now when we rotate it, I'm going to get a shape that makes sense. It isn't going to be wonky because it has a beautiful symmetry to it, okay? But the question is, how do I evaluate it, right? How would 2-unit or 3-unit U evaluate this? Well, I suppose what you would try and do is, and you would need your hand held through this obviously, is you would need to think about something like this which is equivalent but rotated around the right way for us, right? You might consider something like this, which actually you guys would happen to know the equation of. Right? What's the equation of that? X squared. Hold on, stop. Yes, but think about, I particularly think of this guy. It's a simple one, isn't it? Is it going to be y squared first? Y squared minus x squared? Because we're used to these guys, aren't we? They're more common, right? That just equals 1, because it's rectangular, all right? So I suppose you could do this, right? And being told in advance that this is equivalent to that, but rotated around, I suppose you could then kind of argue, okay, well now consider it around the y-axis or whatever's convenient, and do it the normal way. You would do a volume. Cool, okay? Except there's a whole bunch of assumptions built into that process, right? And you'd have to have your hand held through that an enormous amount, right? It just so happens that it wouldn't actually be that hard, would it? Like, think about this. Because you would integrate, if we were going around the y-axis, I suppose that means you would integrate x squared dy. And x squared is quite easy to get out of that, isn't it? Right? That's interesting. We might keep that in our back pockets for later. Let's consider what happens if we just think about this guy as he is, right? Because the great thing about it is, you could still work out what annulus you will get and all that kind of thing, even if it's oriented in a different way. You just need to be a bit careful with your coordinate geometry. Okay? So here's what we're going to do. If I want to think about this at a different angle, right? I actually don't really need to worry about angles so long as I have the right distances, right? Think about this annulus, you know, if I gave you an annulus like this, okay? And if the inner and outer radius, inner and outer radius, if they were well defined and you knew what they were, it wouldn't matter which way you held it. It would still have the same volume, okay? So if I can work out, well, let's just consider this area in here. You got 4 and 4 here, which makes the equation of this line, what's that? 4 minus x. What is it? Okay. If I can work out what this radius is, that'll be my radius, right? If I'm rotating around this axis here, okay? And if I can work out what the height will be, like where these boundaries are, then I'm home. I don't care about the orientation, okay? So let's give this a go. I'm actually going to call this, oh no, I'll leave it as that. I'm going to define this here as h. Okay. So what I'm after is, I want r in terms of h. How am I going to do that? And you've got some Pythagoras happening, haven't you? Okay. For instance, if I draw in this side here, whoops. There you go. There's a right angled triangle. Okay, and I've got some relationships there which I can use, and I will use them. Okay, but before I get there, how can I get a relationship between these two? I can use perpendicular distance, can't I? That's what this is. Like that there. That radius, in fact, I want it to be perpendicular. So how would I write that? Let's see. R equals, what's the perpendicular distance formula? It's absolute value ax1 plus by1 plus c, right? All over. And that comes from Pythagoras, doesn't it? Okay. Now, the question is, what are the a and the b and the c and the coordinates that go into this? I'll have a look. I'm comparing this point over here, thinking about it parametrically, right? You can put this point wherever you want, and x and 1 over x will be the coordinates. Okay. So that there, that's my x1. That's x1, right? And that's y1. Can you see that? That's the point I'm interested in. What are a, b, and c? Where do they come from? They come from this guy, don't they? Right? Yeah, that was what I was looking at, right? I'm thinking about this distance. The look on your faces. Okay, now, therefore, I did it in general form, don't I? This is not in general form. How would you write it? X minus y equals 0. That's general form, right? So you can see A and B and C. Let's do it. A is equal to 1. X1 is equal to x. Cool. B is equal to -1. Y1 is equal to 1 on x, right? Like so. What's C? 0. Cool. What's on the bottom? 1. 1 plus 1. 1 plus 1? 2. Is that right? So you've got this. Oh, sorry. I might put that at the front because that's a bit awkward. There you go. Okay. This is good. This is progress. How can I use this though? That's all in terms of, that's this distance, right? But it's in terms of this guy, which when I'm doing a rotation is not going to be any use to me, right? I need him in terms of this, right? How do I connect them? You've already told me, right? Pythagoras, yeah? Pythagoras. Okay. If I want Pythagoras, I don't actually care about r, right? I actually want r squared. Oops. R squared. R squared is what appears in Pythagoras, right? Which is actually good for me because it gets rid of the square root and it means I don't have to worry about the absolute value, right? So what do I get? A half? X minus 1 on x squared. Is that okay? That's r squared. How do you connect that to that? I'll give you the start. You give me the end. What do you put in there? Come on, we can work this out, can't we? Surely. What are the shorter sides? What are the shorter sides? R squared and h squared. Wow, that was hard. It is late in the afternoon, isn't it? Okay, here's the tricky part. What's the hypotenuse? The hypotenuse. There's the hypotenuse, right? How would you work out what the length of that is? Come on, we know what it is, right? Just distance formula. I know what the coordinates are, right? It's the square root of x1 minus x2 plus, all squared, sorry, plus y1 minus y2, all squared. Is that okay? That's right. Cool. Just as convenient to me. I don't want the square root, right? I just want the thing squared. I get this. Oh, I'm really close. Look at this. What did I want? What did I want? What was I after? I was after a connection between the radius and this distance, because they're perpendicular to each other. They're going to correspond to the total height and the radius of the annulus, right? That's good. I'm so close. I'm not there yet though, am I? What can I do? What's the culprit? I want R's, I want H's. What do I need to get rid of? I need to get rid of all this x garbage over here. Right? How do I get rid of all that? Well, I've got all of this stuff almost up here, don't I? Right there. How am I going to get this? How do you twist and turn this in order to get that out? Have a go. Have a go. I'll give you 30 seconds. Have a go. Got it? How did you get it? What did you do?
You expand it.
Okay, so that gives you?
Oh no, you times the 2 over to the R squared.
Okay.
Yeah. And then you
Now
expand
what?
it, so it's x squared minus 1 plus 1 over x squared.
Cool.
And
Cool.
then
Very cool.
you plus
So you got 2r squared over here, right? And the difference between this and this is just the 1, isn't it? Okay. So I'm going to add 1 to both sides. Is that right?
2.
Oh, of course. Didn't you say 1? You said 1.
I said 2. You should watch the video.
Should I check? Should I check?
Yeah, watch the video again.
I'll check it later. Okay, fine. 2. I get rid of that 2. Kick it over. It becomes plus 2, right? Yeah? Cool. That is really good because that's exactly what I can get rid of over here. Good. Let's do that. R squared, h squared. What do we say? 2r squared plus 2. Okay. I suppose there's a variety of ways that I could write this. Probably the most useful way is to make r squared the subject. What are you going to get?
Yeah, played.
This guy comes over, this guy goes over. Yeah? Is that alright?